Hi everybody, Mrs. Pesic here. We are looking at section 1.3, linear equations in two variables. Your objectives are to use slope to graph linear equations in two variables, find the slope of a line given 2 points on the line, write linear equations in two variables, use slope to identify parallel and perpendicular lines, use slope and linear equations in two variables to model and solve real-life problems. Let's take a look at our first example. In this case, let's review how to graph lines that are in slope-intercept form. So slope-intercept form is y equals mx plus b. All right, so that's this form right here. And so if we were going to graph y equals 2/3 x minus 2, we would have a slope of 2/3 and a y-intercept of -2. So to graph that, we would put a little point at that y-intercept and move according to the slope. So we go up 2 and to the right 3, that put us right here, or down 2 and to the left 3, that will put us right here, and then we can draw our line like this. All right, what if we were graphing y minus 5 equals 0? If we're going to graph that one, copy this, get another grid there, and let's get another one on here for good measure. So if we're going to graph, let's do this one over here, but we're going to do this one right now. If we're going to graph y minus 5 equals 0, then I would just add 5 to both sides and see that I get y equals 5. Now, y equals 5 is either a horizontal line or a vertical line. Do you remember which one it is? If you forget, you can always make a chart, fill in 5s for all the y's, since y has to equal 5, and fill in whatever you want for the x's. So like 0, 5 would be right here. Maybe not. So let me slide that guy down a little bit. 1, 5 would be right here. 2, 5 would be right here. And it sure looks like it is forming a horizontal line. And the slope of horizontal lines are always 0. What about this one over here? If I take x plus 1 equals 0 and I subtract 1 from both sides, I get x equals -1. That one is going to be a vertical line. You could test that if you want with ordered pairs. Just fill in -1s for all the x's and whatever you want for the y's. And we'll have -1, 0, -1, 1, -1, 2. And so our graph is going to look like this vertical line here. All right, vertical lines have an undefined slope. So slope here is undefined. All right, so that's graphing lines. Let's take a look at just a little summary then. So if it's x equals some number, it's going to be a vertical line with an undefined slope. And if it is y equals a number, like y equals 2 or y equals 5, then the slope is going to be equal to 0. This one had an undefined slope. All right, so that's a little summary about horizontal and vertical lines. Let's just review what slope is all about. Slope is the rise of a line divided by the run. And so our slope formula is the change in y divided by the change in x. But you might be more used to seeing it in the form y2 minus y1 over x2 minus x1. So if we're going to find the slope of some ordered pairs, we can use that formula. So for here, if I want to find the slope, I'm going to do difference in the y's over difference in the x's. So for example, this is like my x1, y1. This is my x2, y2. That's supposed to be a 2. And so I would do -6 minus 1 over 2 minus a -5. And I'm going to get -7 over, looks like a +7. So my slope is going to be -1 for that first example. In my second example here, if I try and do a slope here, I'm going to do difference in my y's, so -2 minus 3 over difference in my x's, which is -7 minus a -7. So I'm going to get -5 over plus a positive. It's going to be -5 divided by 0. We're not allowed to divide by 0, so anytime we do, it is undefined. I'm going to abbreviate. And if the slope is undefined, what does that tell you about the line that goes through these 2 points? It must be a vertical line. I'm abbreviating. All right, let's take a look at this last example here. If we're going to try finding the slope here, the slope difference in the y's, that's 4 minus 4 over 6 minus a negative 3. I'm getting 0 over 9. If my 0 is in the numerator, that's actually equal to 0. So that would be a horizontal line. All right. Okay, and just to back up a second, what would be the equation of this vertical line up here? Well, it's going to be the line, the equation of the line where we're always going through x equals -7. I see -7, 3, -7, -2. So the equation here would be x equals -7. That would be the equation of our line. And for this one, it's a horizontal line, and all of the y's are equal to 4. So that one, our equation would be y equals 4 as our equation. All right, let's talk about point slope form of a line. So that's y minus y1 equaling m as our slope times x minus x sub 1. All right, and this first example says write the point slope form of the line that passes through -8, 3 and has a slope of 1/2. So if I'm going to do this, I'm going to use -8 as my x1 and 3 as my y1. So I'm going to write y minus 3 equaling, I need my slope, which is 1/2, times in parentheses x minus my x1. So x minus a -8. And we can clean that up a little bit and say x plus 8. Now it says put the line into slope-intercept form. So I would probably distribute this 1/2 here. So I've got y minus 3 equaling 1/2 x plus 4. And then if I add 3 to both sides, so I can get it into y equals mx plus b form, I'd have y equals 1/2 x plus 7. So if I graph this line, or if I graph this line, they're going to be identical lines. They're just written in 2 different forms. All right, let's talk about parallel lines. Parallel lines have the same slope, and I could actually kind of add to that definition a little bit and say parallel lines have the same slope but different y-intercepts. All right, parallel lines have the same slope but different y-intercepts, whereas perpendicular lines have slopes that are opposite reciprocals, and their y-intercepts may be different, they may be the same, doesn't matter, but their slopes are opposite reciprocals. So let's use that idea, those ideas, to do this first example. We're going to find the slope-intercept form of the line that passes through -4, 5 and is parallel to this line 2x minus 3y equals 6. Well, we know the slopes are going to be the same, but it's kind of hard to figure out what the slope is when it's in this form. So let's put this into y equals mx plus b form. So I'm going to subtract 2x from both sides. I get -3y equaling -2x plus 6. And if I divide both sides by -3, I get y equals 2/3 x minus 2. I think that looks right. Y equals 2/3 x minus 2. So now I know that my slope is equal to 2/3. So when I'm writing our equation of our line, I know I want my slope to be 2/3. I know I don't want my y-intercept to be -2, right? That's got nothing to do with us. But I do know that the line has to pass through -4, 5. So I'm going to call that my x and this my y. So I would just go to 5 equals 2/3 times a -4 plus b. And then I'm going to have to solve this equation. All right, so here we are going to have to multiply 2/3 times a -4. So it looks like 5 equals -8/3 plus b. And then, let's see, I'm just going to keep sliding this other problem down a little bit further. And so in this case, we do need to get b by itself. So we're going to add 8/3 to both sides. So if I add 8/3, I'm getting, let's see, B is equal to 5, which is same as 15/3. That's my 5, plus 8/3, and that looks like 23/3, I believe. And so if that is the case, then my final answer for this equation is going to be y equals 2/3 x plus 23/3. All right, that's the equation of a line that's parallel to this line, but is passing through -4, 5. All right, let's take a look at this next example. So for this one, we are going to want to find the line that is perpendicular to this line. But again, it's still got to go through that same ordered pair. So if I find the slope here, I got to put it into y equals mx plus b form. All right, and so we're going to have to subtract 4x from both sides, and I get 2y equaling -4x plus 10. And then if I divide everything by 2, I get y equals -2x plus 5. And so our slope here is -2, but we want the opposite reciprocal because we want the line that's perpendicular. So the slope is going to be +1/2. All right, and so we're going to use the y equals mx plus b form, and we're going to plug in 1/2 for the for the slope. So I'm going to put 1/2 in here, and I got to go back up and check what was the line. We wanted it to go through -4, 5. So I'm going to plug in 5 for y and -4 for x. All right, and so in this case, I get 5 equals -2 plus b, and adding 2 to both sides, I get that the y-intercept is equal to 7. So my equation should be y equals 1/2 x plus 7. So this line is going to be perpendicular to this line, and not only that, it's going to pass through -4, 5. All right, let's talk about this. We got a pizza shop, and they purchase a new oven that's worth $5,000. The oven has a useful life of only 7 years, and then the salvage value at the end of the 7 years is $1,500. So you are to write a linear equation that describes the book value of the equipment each year. So let's say we make a little table of the year that we've owned this oven and its value. All right, so year 0, we just buy this oven and its value is $5,000. And 7 years later, its value is only $1,500. So we want to find the slope, and to find the slope, we're going to do 5,000, difference in the y, so 5,000 minus 1,500, divided by difference in my x's, 0 minus 7. So I think I get 3,500 divided by -7. And I think that looks like it's going to be -500. So it looks like it's dropping in value $500 each year. All right, and so to write the linear equation, we can say, hey, the value, let's use v for value of this, is going to be -500, that's our slope, times x, where x is the number of years we've owned this. But then we need the starting value. So it's starting out at $5,000. So maybe it might have even made more sense to not write it in like y equals mx plus b form, but say, hey, our value is going to be $5,000, but then we want to subtract the value $500 every year. So either way, you can write it like this or like this. All right, and that's it for this video. Thanks for watching.